You are listening to The Vocal Technologist. Spoken Tech for your ears.
Welcome. We're back with another look at some really interesting developments in tech. We've sifted through a bunch of sources to bring you the stuff that really stands out. The goal today, like always, is to give you those key insights, maybe some surprising facts, without burying you in information. We're looking at how things are being built smarter, more observable, and definitely more secure. First up, something pretty foundational is getting a makeover. SQLite. Heard about this thing called Turso. It's being called the next evolution.
Yeah, it's really quite something. Taking SQLite, which is everywhere, and adapting it for, well, today's world-distributed systems, AI workloads.
Okay, let's unpack that. I mean, SQL is known for being super reliable, kind of the definition of stable. So why rewrite it? How is this an evolution? What makes Turso, necessary?
Well, it's interesting. Turso isn't just about being a slightly faster SQLite. It's more about rethinking how local-first apps can work with the cloud, especially an AI-driven cloud. It's built in Rust, and it's specifically designed for concurrent stuff, AI workloads. Key things are its async API, so it handles lots of things at once without getting stuck, and native vector search.
Vector search, right? That's huge for AI, isn't it? For finding similar concepts, not just exact matches.
Exactly. Find images like this one.
Yeah.
And Turso builds that right in. So it's trying to bridge that gap between a local database and global scale AI features.
So enabling new kinds of apps, really, making local feel global.
That's a good way to put it. And besides the new features, they're really pushing reliability. They use advanced testing, like fault injection, simulating failures.
It's actively trying to break it.
Yeah, basically, to make it even more robust than SQLite already is, which is saying something. It's pretty compelling taking something familiar and making it demonstrably tougher for serious production use.
Okay, so Turso is about a stronger data foundation. But once you have all these services running, data flowing everywhere, how do teams actually keep an eye on everything? It gets chaotic, right? Logs, metrics, traces all over the place.
It definitely does. And that brings up the whole challenge of observability.
Yeah.
How do you get one clear picture when the data is coming from, dozens of different tools and services? That's where something like OpenTelemetry comes into play. Think of it as like a universal translator for system health data.
Translator.
Yeah. It's an open source framework that standardizes how you collect, process, and send out all that telemetry data, your logs, performance metrics, traces, everything your systems generate.
So you instrument your code once to send data, and then OpenTelemetry handles getting it to whatever monitoring tool you use. No more vendor-specific agents everywhere.
Precisely. That's the key benefit. Vendor-agnostic instrumentation. Code it once, send it anywhere that supports the standard. It helps break down those data silos so you can actually correlate information across different services. We've seen it used really effectively for monitoring tricky stuff like Kafka clusters. Kafka's great because it's decoupled, but that makes tracing a single message flow end-to-end notoriously difficult. OpenTelemetry helps connect those dots.
Okay, that makes sense for operational health.
Yeah.
But let's switch gears slightly to security. It's amazing how critical things can sometimes hide in plain sight, right?
Yeah.
Especially with infrastructure as code, like Terraform state files.
Oh, absolutely. This is a huge one and often overlooked. If you're not careful with how you store your Terraform state files, especially in cloud environments like Azure, you could be in real trouble.
How so? What's actually in those files?
Well, potentially a lot of sensitive stuff. We're talking access tokens, service principal credentials, sometimes even plain text passwords for databases or other services defined in your config. If those files leak, it's like handing over the keys to your kingdom. A major breach risk.
Wow, okay.
Yeah.
That's bad. So what are the absolute must-dos, the best practices to lock these down?
Right. Essentials include stop using shared access keys for the storage, isolate the storage accounts using private endpoints, definitely use Azure AD authentication, not just keys, and enforce things like versioning on the state files, turn on logging, and have a disaster recovery plan. It really prompts a question for everyone listening. How secure are your infrastructure state files right now? Seriously, it's worth checking, like today.
So wrapping up here, we've touched on quite a bit. Turso reimagining SQLite for modern apps, OpenTelemetry creating a common language for observability, and the critical need to secure infrastructure state files. The common thread seems to be about building more resilient, understandable, and fundamentally secure systems, even as the tools themselves evolve.
Exactly, and it leaves us with a thought, doesn't it? In this tech landscape that changes so fast, where even bedrock tools are being reinvented, how do you strike that balance? Adopting the cool new stuff while sticking to those timeless principles of robust security and really understanding what's going on under the hood. Something to think about.
Spoken Tech for your ears.